All right, so the remainder theorem. Really, really, really important. Time that you see theorem, I should be wide open and saying, I need to know this. So this is the remainder theorem. So when a polynomial, p of x, is divided by a divisor, x minus a, then the remainder is given by the p of a. Take 2 minutes to try to decipher what this simple sentence means and the consequences of it. When a polynomial p of x is divided by x minus a. What? Okay, let me try to make sense of that. Have I done an example? Can I think of an example? Sure, I can think of an example. Let me use the example that was above. Now, let me try to rework this. When a polynomial p of x, we did do a polynomial p of x, is divided by x minus a. That's what I have. Feel good with this example. Then the remainder is given by the p of a. What? We're talking about, if I do this division, the remainder is equal to the p of a. What does this mean? Well, it really means that the remainder, we don't have to do the remainder, or we don't have to do the division to figure out the remainder. Now, this is going to be important. All we have to do is figure out the p of a, whatever that is. But if our divisor is x minus a, there's no coincidence that this says x minus a and there's an a there. So if our divisor is x minus a in our example, here, if we want to calculate the remainder, a is equal to 2. The p of a. Now what does the p of 2 mean? It just simply means plug in 2 into your polynomial. Oops, sorry, my mistake. A little bit of math in my head. If you calculate this out, I think 2 to the power of 4 is 16. Minus 2 times, now watch your order of operations because you have to multiply first. 2 cubed is 8 times 2 is 16. Minus 2 squared is 4. Plus 7 times 2 is 14. Minus 4. And what we get is our remainder is 6. Oh my God, that's exactly what I had. So part of the reason why I'm using an example to demonstrate this is because it makes it more clear. I hope it makes it more clear. Whenever I'm trying to understand something quite difficult, and I don't know if the remainder theorem is quite difficult, it's definitely wordy in one sentence. I go with what I know already and try to expand from there and work that example. Why might the remainder theorem be so important? In essence, this is a shortcut to find the remainder without doing the division. It is important when when trying to identify if x minus a is a factor of p of x. What does this have to do with factors? Again, last example with numbers. Is 3 a factor of 17? Everybody at home is saying, no, I can hear you from here. So anyways, 3 goes into 17 5 times with a remainder of 2. The reason why 3, or we can demonstrate that 3 is not a factor because we have a remainder. Now, is 3 a factor of 21? Yes, everybody says. 7 and it's a remainder of 0. Since it's a remainder of 0, 3 is a factor of 21. Using the same logic, we'll approach this next lesson, is x minus 2 a factor of that polynomial? The answer is no, because the remainder's not 0. I hope this helps. Let's get moving on to doing some math.